Hi, in this video we are going to discuss VSEPR model. In the previous video we have discussed some basic assumption point and the rules to assign the geometry of molecules, which were developed by Sidgwick and Paul and modified by Gillespie. In this video we will apply some basic assumptions point and the rules of the VSEPR theory to assign the geometry of molecules. ABE. This is the general formula of VSEPR model. Here A is the central atom, B is the bonded atom with central atom, and E is the number of lone pair electron on the central atom. Let us start from the first system of VSEPR model, which is AB2 system. In this system, A is the central atom which is bonded with two other atoms, and in this system the central atom having 0 lone pair electrons. For example, we see that the compound of group 2 elements form this system, like beryllium chloride, beryllium bromide, cadmium chloride, etc. In all these compounds, the central atom is bonded with two other atoms and having 0 lone pair electrons. This is the geometry of beryllium chloride, carbon dioxide, neutronium ion, and hydrogen cyanide. The geometry of all these compounds is linear, and these all compounds belong to AB2 system. As we have discussed that multiple bonds do not affect the geometry of molecule, these compounds having single, double and triple bond have the linear geometry and having bond angle 180 degree. And in this system all the central atom are sp hybridoids having maximum bond angle and minimum repulsion. AB3 system. Here is the central atom which is bonded with 3 other atoms and having 0 lone pair electrons. For example, we say that the compound of the group 3 elements like boron trichloride, boron trifluoride, aluminum trichloride, etc. or belong to AB3 system. This is the geometry of aluminum trichloride. Here aluminum is the central atom which is bonded with other 3 atoms having 0 lone pair electrons. Here the bond angles are 120 degree and the geometry of this molecule is trigonal. This is flat or planar molecule. Carbonate ion. This also belongs to AB3 system, but here the bond angle is not exactly 120 degree. As in COCl2 molecule. Here the double bond do not affect the geometry, but having the greater charge density cause greater repulsion. So due to greater repulsion, the bond angle reduced from 120 to 111.4 degree. And here bond angle increased from 120 to 124.3 degree. But the geometry of all these molecules are trigonal and all the central atoms are sp2 hybridoids. AB2E system. This is the subsystem of AB3 system. Here the A is the central atom which is bonded with two other atoms and having one lone pair electron. For example, sulfur dioxide SnCl2 molecule or belong to AB2E system. This is the geometry of sulfur dioxide and SnCl2 molecule. Here the central atom having one lone pair electron and bonded with two other atoms. So these belong to AB2E system. And as the lone pair electron cause greater repulsion as compared to bond pair electrons, so the bond angle decreases and the bond angle is less than 120 degree. The electronic geometry of these molecules are trigonal, but the geometry of molecules are weird band shape. And the central atom in this system is also sp2 hybridoids. AB4 system. Here is the central atom which is bonded with 4 other atoms and having 0 lone pair electrons. For example, compound of group 4 elements like CH4, CCl4, SiF4, etc. All these molecules belong to AB4 system. This is CH4 molecule. This is not planar molecule. The bond angles are 109.5 degree and the geometry of this molecule is tetrahedral. And here the central atom is sp3 hybridoids. Ammonium ion, which have one coordinate covalent bond, sulfate ion, and ClO4 anion. These compounds are also belong to AB4 system having tetrahedral geometry and the central atoms are sp3 hybridoids. AB3E system. This is the subsystem of AB4 system. Here is the central atom which is bonded with 3 other atoms and having 1 lone pair electron. For example, NH3PI3 molecules belong to AB3E system. This is the geometry of NH3 molecule, which have 1 lone pair electron and 3 bonded atoms. Here, the lone pair electrons cause greater repulsion, so the bond angle decreases from 109 to 107 degree. And the electronic geometry is tetrahedral, but the geometry of this molecule is trigonal pyramid. In this subsystem, the central atom is also sp3 hybridoids. AB2E2 system. This is also subsystem of AB4 system. Here is the central atom which is bonded with 2 other atoms and having 2 lone pair electrons. For example, water, hydrogen sulfide Cl2O molecules or belong to this system. This is the geometry of water molecule. Here, the central atom oxygen has 2 lone pair electrons and 2 bonded atoms. These 2 lone pair electrons cause greater repulsion, so the bond angle decreases from 109 to 104 degree. And the bond angle in hydrogen sulfide is 92 degree, which is due to greater size of sulfur or greater repulsion. The electronic geometry of these molecules are tetrahedral, but the geometry of these molecules are V-shaped, and here the central atom is also sp3 hybridoids. AB5 system. Here is the central atom which is bonded with 5 other atoms and having 0 lone pair electrons. For example, compounds of group 5 elements like PCl5, AsCl5, PF5, etc. belong to AB5 system. This is the geometry of PCl5 molecule. Here phosphorus is central atom which is bonded with 5 other atoms having 0 lone pair electrons. And the geometry of this molecule is trigonal bipyramid, as this form trigonal shape and 2 pyramids. So the geometry of all the molecules belong to AB5 system is trigonal bipyramid. In this molecule, there are two types of bond. One is axial bond and other is equatorial bond. The two bonds which are above and below the plane are axial bonds, and the three bonds which are on plane, these are equatorial bonds. And the bond angle between axial equatorial bond is 90 degree. Bond angle between equatorial bond is 120 degree. And the bond angle between axial bond is 180 degree. So there are three kinds of bond angles. Axial equatorial bond angle, which is 90 degree. Equatorial bond angle, which is 120 degree. And axial bond angle, which is 180 degree. Axial bonds are weaker as compared to equatorial bonds. In chemical reaction, by heating PCl5, first axial Cl removed because of larger bond length and weaker bond strength. This is because axial have less space to occupy or less bond angle, and more steric is there, so these are less stable. After removing axial chlorine, this form Ab2E system, and in Ab5 system all the central atoms are sp3 dihybridized. Ab4E system, this is the subsystem of Ab5 system. Here is the central atom which is bonded with 4 other atoms and having one lone pair electron. For example, SF4, TeCl4, HCl4 all belong to this system. This is the geometry of HCl4 molecule. Here one lone pair electron cause repulsion, so the bond angle become less than 90 and less than 180 degree between axial equatorial bond and axial bond. The electronic geometry is trigonal bipyramid, and the geometry of this molecule is seesaw, and the central atom is also again sp3 dihybridized. Ab3E2 system. This is the subsystem of Ab5 system. Here is the central atom which is bonded with 3 other atoms and having 2 lone pair electrons. For example, ClF3 molecule belong to this group. This is the geometry of ClF3 molecule. Here the central atom has 2 lone pair electrons which cause greater repulsion, so the bond angle become more or less than 90 degree between axial equatorial bond and more or less than 180 degree between axial bond. So we can summarize as the number of lone pair electron increase, the repulsion increase, and the bond angle decrease. The electronic geometry of this molecule is trigonal bipyramid, and the geometry of this molecule is T-shape. And the central atom is again sp3 dihybridized. Ab2E3 system. This is also subsystem of Ab5 system. Here is central atom which is bonded with 2 other atoms and having 3 lone pair electrons. For example, XeF2 molecule belong to this system. This is the geometry of XeF2 molecule. Here the central atom have 2 bonded atom and 3 lone pair electrons. One lone pair electron on one side and 2 lone pair electron on other side cause repulsion and form the geometry of this molecule linear. Although the electronic geometry is trigonal bipyramid and the central atom is sp3 dihybridized. Ab6 system. Here is central atom which is bonded with other 6 atoms and having 0 lone pair electrons. For example, compound of group 6 element like SF6 molecule belong to this system. This is the geometry of SF6 molecule. And the geometry of this system or this molecule has 8 heads. 4 heads on one side and 4 heads on other side. So we say that the geometry of this molecule is octahedral, having 8 heads. In this system or molecule, there are also two types of bond angles, which are 90 degree and 180 degree. And the central atom may have sp3d2 or d2sp3 hybridization. AB5E system. This is the subsystem of AB6 system. Here is the central atom which is bonded with 5 other atoms and having one lone pair electron. For example, Br F5, IF5 molecules belong to this system. This is IF5 molecule. Here the central atom iodine is bonded with 5 other atoms and having one lone pair electron. The electronic geometry of this molecule is octahedral, and the geometry of this molecule is square pyramid. As this forms square shape or pyramid shape, so we say that the geometry of this molecule or this system is square pyramid. Here, one lone pair electron causes repulsion, so the bond angle becomes less than 90 degree. And the central atom has sp3d2 hybridization. AB4E2 system. This is also the subsystem of AB6 system. Here is the central atom which is bonded with 4 other atoms and having 2 lone pair electrons. For example, XeF4 molecule belong to this system. This is XeF4 molecule. Here the central atom is bonded with 4 other atoms and having 2 lone pair electrons. And the geometry of this molecule is square planar geometry. Although the electronic geometry of this molecule is octahedral. Here, this system or this molecule have 2 lone pair electrons which cause greater repulsion and the angle becomes more or less than 90 degree. We can verify this system as Xe belong to 8th group, having 8 valence electrons, 4 involved in bonding and 4 valence electron form 2 lone pair electrons. So this is AB4E2 system. And in this system the central atom is also again sp3d2 hybridized. So we also summarize in this system as the number of lone pair electron increase and the number of bond pair electron decrease, repulsion increase and the bond angle decrease. These are AB6, AB5E and AB4E2 systems, which represent as the number of lone pair electron increase, the bond angle decrease. AB7 system. Here is central atom which is bonded with 7 other atoms and having 0 lone pair electrons. For example, compounds molecule of the group 7 elements like IF7 form this system. This is IF7 molecule. Here iodine is the central atom which is bonded with 7 other atoms and have 0 lone pair electron. And the geometry of this system or this molecule is pentagonal bipyramid. As this molecule form pentagonal shape and 2 pyramids. one pyramids on one side and other pyramids on other side. So the geometry of this molecule or this system is called pentagonal bipyramid. This system also have three types of bond angle as AB5 system. The bond angle between equatorial bond is 72 degree. The bond angle between axial bond is 180 degree and the bond angle between equatorial axial bond is 90 degree. So we can say this system has three types of bond angle: axial equatorial, which is 90 degree, axial which is 180 degree, and equatorial which is 72 degree. In this system, the central atom has sp3d3 hybridization and the geometry is pentagonal bipyramid. Thanks for watching and please comment if you have any question.